Hi, welcome back, and this is Subramaniam from Information Security Solutions, connecting with you for the CISSP lecture. Yeah. Now, this is the fifth video in this particular series, and we're going to have a look at what do we mean by substitution cipher and the transposition cipher to a possible extent on what is the stream cipher and a block cipher. So there had been a great news and great histories across the world on the cryptography, wherein every country has got its own history. For example, if you take the history of the Greeks, it goes to around 500, 600 BC on usage of cryptography, and Chinese has used it, and Indians have used it. In fact, there's a mention about the cryptography in the greatest epic Mahabharata, which dates back 5,000 years, where the conversation is known only to the sender and the receiver, okay, the speaker and the listener, okay, in the assembly of a lot of people. So in the Indian history, it's actually called as a mixed vikalpa. But let's not get too deep on the history part of it now. Coming on to what is called as a substitution cipher and transposition cipher. Now, substitution cipher, as the name says, you are going to substitute the plain text with something else. Attack at the dawn, okay, so assuming the plain text PT, take PT is the plain text, assuming that I am using a key of +3, and attack at dawn becomes A becomes the third alphabet from its position, so A becomes D, D becomes T is UVW, okay, W again, it becomes D, and C becomes DEF, and K becomes LMN, AT becomes DW, TH becomes T becomes W, and IJK, FGH, T becomes FG, EFG. And A becomes D, and this becomes Z, and N becomes OPQ. Okay, so this is ciphertext. Now, if you actually look at the substitution cipher, it actually reveals a pattern. Okay, ATTA becomes DWWD, and ATTS DWWD if the key is 3. So the key doesn't change, and the plain text doesn't change. The ciphertext also does not change. This is something that we discussed when we discussed about the initialization vector, if you remember. Correct. Yeah. So keys +3 and attack at the dawn becomes DWWDFN, DWWKH, GDZQ. Okay, that's the ciphertext. This is substitution cipher. So substitution cipher, as you all know, it reveals a pattern. Okay. Just to touch upon the initialization vector IV, if the IV is lemon, okay, we need to use the initialization vector to the length of the plain text. Okay, so the plain text is this one, and the initialization vector is LEMON, LEMON, okay, but the actual encryption of the space is also taken into consideration, but for the sake of understanding, I have not taken the space here. Okay, so with the initialization vector, let's call this as an the intermediate value which we want to get up, because we have not done with the key. Okay, A, B, C, D. X, Y, Z. Yeah. So let's use the row size and vector. 1, 2, 3, 4, the key. Pull it. Make it 26. Yeah. Now, initialization vector. This becomes A plus L. A is 1, and then L is 12, and I get what is called the 13 here. 13 is actually M. Okay, but I haven't added the key. If I add the key at 13, let's put M here. Okay, I have not added the key. So this becomes 16, and 16 is actually T. Yeah. Next one, T and E. Okay, so T is here, T is 20, and E is 5. Okay, so this becomes 25. 25 plus 3 becomes 28. Modulo 26, 28 will actually become B. There are 26 alphabets in English, so if you say 28, then it becomes 26 plus 2. Okay, or rather 28 minus 26. So T and M, T becomes 20. Okay, and then M becomes 13. Okay, so 20 and 13 becomes 33. 33 plus 3 becomes 36. So 36 minus 26 is 10. So we get J. Okay, if you actually see, even the DWW, okay, is not DWW, it's PBJ. It's PBJ. Okay, now the mono alphabetic cipher. Okay, A is always D, T is always W. Okay, becomes a polyalphabetic cipher. Okay, with an introduction of the initialization vector. So with the initialization vector, the advantage is we don't get to know the pattern. Okay, we cannot have a different key for every encryption, right? There is a situation in where, or there is an algorithm in where we have a different key per packet. That's actually called as an WPA. Okay, so it's actually based on temporal key integrity protocol that we'll discuss when we come to the network security section. But for now, okay, if the key is same and the plain text is same, if the initialization vector is not there, okay, it's absent, then you have what is called as an the cipher text revealing a pattern. Okay, so like what we discussed now. But if you have an initialization vector, it will not reveal a pattern. So the monoalphabetic cipher will actually become a polyalphabetic cipher with the introduction of the initialization vector. So that introduces a complexity. Now, let's get on to what is called the transposition cipher. Okay, transposition cipher. So attack at the dawn is my plain text. Now, if I want to say key is 4, okay, I'm assuming key is 4. Let me write down my plain text without the space. So key is 4. I'm separating it. I'm using F as a Z as a filler. Okay, so 4 characters. The key is 4. Now what I'm going to do is I'm going to bring the rows onto a column. Okay, transpose of a matrix. Okay, that's what the transposition is. Now take the first row, ACTA, TKHW, TAEN, ATTZ. Okay, that actually becomes a ciphertext which I'm sending it to the destination. This is my ciphertext. The destination, what actually happens is at the receiver, okay, the receiver receives the message and he is going to convert rows to the columns. Okay, so he takes the first row, ADTA, CKAT, THED, AWNZ. Okay, so I'm going to remove the spaces. I can logically divide this as attack D dawn, and I know this is going to be a filler. Yeah, this transpose of a matrix. Okay, transposition cipher. If I do the substitution and the transposition multiple times, okay, with the different keys, I call it a super encryption. Is equal to substitution plus transposition. Okay, multiple times. substitution, transposition multiple times. Both. Let me put this. Now, every algorithm that we actually going to discuss, okay, especially the symmetric encryption. Okay. The symmetric encryption we are going to discuss about number of times the confusion and diffusion actually happens. So diffusion is a mathematical intensive way of doing a substitution transposition. Okay, so data encryption standard was 16 times of confusion. Diffusion triple this is 48 times. AES 10 times, 12 times, 14 times, depending upon the key size is 128, 192, or 256, which we are going to have a discussion later. So this was the substitution and the transposition basically is. Yeah. So next video we will be discussing about the stream cipher and the block cipher. It is more or less on the same lines. Okay? And then let's take a few Vijaya cipher illustration and playfair cipher illustration, etc. And what is the one-time pad before we start discussing about the cryptography algorithm. The popular one is the data encryption standard that we are going to start. Cheers then, have a good day, happy laying, stay connected, subscribe to my channel, and wish you all a very good luck towards your CISSP certification. And of course, you can also follow this lecture for certificate advanced security practitioner and the security plus from the Great Foundation. Cheers.